And then three things can happen with this ratio. Number one, and this is as the limit goes to infinity. If the limit as n approaches infinity of this ratio, the absolute value of a sub n plus 1 over a sub n equals some limit L, and L is less than 1, then the series is absolutely convergent, and then convergent as well. So if the limit of that ratio equals some number L, and that number L is less than 1, then the series as n goes from 1 to infinity of a sub n is absolutely convergent, and therefore it's convergent. So the ratio test and the root test are really going after something stronger than just convergence. It's going after absolute convergence. And the second part of this test is if this limit equals some number L and it's greater than 1, or the limit does not exist or equals infinity, then the series is divergent. So if the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n equals some number L, and that's greater than 1, or the limit as n approaches infinity of this ratio of a sub n plus 1 over a sub n, if that equals infinity, then the series, the sum of a sub n, is divergent. Okay, what am I missing? If it equals 1, is that why you had your hand up, Lex? Okay. All right, so we're missing equals 1. That's part 3. Part 3 is this: if the limit as n approaches infinity of that ratio equals 1, the ratio test is inconclusive. We have to try something else. So if the limit as n approaches infinity of a sub n plus 1 over a sub n equals 1, then the ratio test, the book says is inconclusive. I'm going to put is no good. So we have to try something else. We cannot conclude whether it converges or diverges. Is no good. We must try something else. That's the stuff in the beginning of the chapter. Lex?
If our ratio is negative infinity, does it fall under case 1?
Well, you know what though? Since we're doing the absolute value, it's going to be...
And the second part of number 2, those are both the same. Well, not the same. The second part is true, the first part always is true, right? Like it's redundant.
No, this and this?
Yeah.
No. Well,
Because
it could...
Infinity is always greater than 1.
But it could equal... L could be 2.
Right.
And which is greater than 1.
The second part.
And it could be infinity. Oh, I see what you're saying. This is saying if it equals a particular number.
Okay.
So technically a limit if it exists, it's going to equal a number. This, from 1550, this right here, they say really a limit equaling infinity doesn't really make sense. That means it does not exist. But when you write equals infinity, you're just saying how it does not exist. So we use this notation, but technically for limits, it's not the best. Okay, so there's the ratio test.